Assalamu alaikum. My name is Abdurrahman Yusuf. My matric number is BEE10103. We want to present our group project. So I will present the question 1. So this is the question 1. If the current in 9 milliampere inductor is high, or current is equal to 2 exponential power -2 time 10 hyperbolic for the times time. So the first question, or the question 1, or question A, is plot a graph of the current as time. So this is the MATLAB code that I use it. So the first line is time factor from 0 to 0.5 seconds, and the second line is this is the time, or this is the current fraction, and this is the plots. So this is what he answered the MATLAB. So we check another time. I will copy the code and I will go the MATLAB and I pass to here. Then I will check. So this is the answer, and this one and my answer is same. And my answer is same. So that's question A. And the second question is answer B, or the question B. Find the voltage across a fraction of time, plot a graph of the voltage by time, and calculate the voltage value. One t is 5 millisecond. So this is the MATLAB code that I using, and this is the first time factor, and this is the current fraction, and this is the inductance. This is the calculating the voltage, and this is the plotting the graph. So this is this is the graph in MATLAB, and this is the output, or the voltage here. This one 7.054, and we will check another time. I will copy the code and I will go the MATLAB. New folder. This one is the voltage, and this is the graph, and it is same. So that's the question B. And the question C is find the power of BT, plot the graph of the power as time, and determine the power when the time is 0.4 seconds. So this is the MATLAB code. All these are the MATLAB code. The first line is the time, and this is the fraction, current fraction, and this is the inductance, and this is the calculate the derivative of the current, and this is the calculate the voltage across the inductor, and this is the calculate the power of BT equal to, this is the formula. This is the formula. Current times the voltage. So, and this is the plotting. So that's what he answered the MATLAB. And this is the graph, and this is the when the time is 0.4, the voltage, the power is equal to 0.8.2 minus 8.2908. So I will check and I will copy the code. And I will go to MATLAB. Then I will paste here. So this is the answer here. 0.4 is equal to 0.8 here. So the same here, this one and my answer the same. So that's the MATLAB, and I will go the manual calculation. So this is the first equation in manual calculation, or the part A. This is the plotting a graph of the current first time. It's here, and it's same from the MATLAB, and this one from the part B. So find the voltage across as a function of time, plot a graph of the voltage first time, and calculate the voltage value when it is 5 milliseconds. So this is the formula that I use it, and this is the current equal to, this is the current, and this is the inductor. So it's differentiation for the current first. This is step 1, and we will use the product rule, and this is the product rule here. So voltage times time is equal to here, and then I will calculate the voltage value when its time is equal to millisecond. So this is the, I use it to substitute where is the t is equal 0.5 or 0.005. Then this is the answer for the value when the time is equal to 5 milliseconds. This is the answer, and this one and the MATLAB code is the same. The last question is here. So I calculate the B, or the power. So this is the formula, the voltage times the current, and this is the voltage times the current, and then the final answer is here. So this one and the last, this one and the MATLAB same. So that's all the question 1. So thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we will continue with the question 2. Question 2, if the current is in 3 millifarad, capacitor is the current formula exponent power of t sine 2t. A. So A, plot a graph of current versus time. So this we will use MATLAB. First, we need to define t. Define and the step of the second 0.001. Then just define the current function. So this is the current function. And to plot the graph, make sure you put figure, then plot the graph current versus time, title, the label of X label and Y label. So we can see here, this is what we got in a manual way. Then if we run the MATLAB, we got this one, almost the same with the manual. It's a little bit different because the manual, when we calculate, we will factorize it a little bit. So we're going to continue with the question 2. Question 2b, find the voltage across as a function of time. Plot a graph of the voltage versus time and calculate the voltage value after t equal to 0.4 millisecond. So firstly, we need to find the function for voltage. To get the function for voltage, the formula is like this. Integrate contrast is almost the same with int. It's the same numerical integral. but I prefer to use Camtrax for integral. Then we need to integrate our our current function and time it with 1 over c. After that, plot the graph. The same, just put the figure, plot title, then make sure you calculate the t equal to 0.4 millisecond. So this is how you want to calculate the voltage. Make sure don't forget to put this, because in millisecond we need to times 10 to the power of -3. Then put index, because we need to find closest index to t equal to 0.4 millisecond. So what we can get here is t equal to 0.4 millisecond. The voltage is -131.44447 voltage. We will get the same when we calculate manually. Yeah, it's almost the same, not exactly the same, but it become like this, the same, because when we calculate we factorize it a little bit, so it will not exactly the same with the MATLAB, because the MATLAB don't factorize. So this is how we got the voltage function. We will use integration by part and need to do the second integral. After we do the second integral, just bring this part here, then times, we will get this final for our integration of current function. So let's move on to the last question, which is question C. Find the energy E. Plot a graph of energy versus time and determine the energy stored at the time. At time t equal to 5 seconds. So to calculate the energy is simple. Just use to calculate energy is very simple. Okay, this one. Here how we calculate the energy. We need to times power of 2 the voltage function, then don't forget to time it with C. After that, just do the same as the question B. Plot the graph, put the index closest to t 5 seconds, then calculate. So this is what I got in the MATLAB. 151.2071 joule. For the manual one, I will get like this, 153, almost the same. Then we will see the graph, how the graph look in MATLAB. This is the graph for energy versus time, almost the same. This one is very steep, the same with our manual one. Also, this graph, almost the same also, voltage versus time graph. This is the reason why I use the range is -1 and 1, so that I can do the manual one more accurately. So that's all from us. Thank you very much.